have a compass, have some tracing paper, have a pencil, have a highlighter. Because in this part 2 of the activity, we're going to talk about the mid-segments. And that's the goal. Note, a mid-segment of a polygon is any line segment that connects two midpoints of the sides of the polygon. So we're going to have this concave shape right here, or maybe it's just one triangle at a time, BST1 and BST. But we're going to draw the mid-segments by drawing them right through the middle, by connecting the lines that go through the middle. The way to do this, like officially, is to use a compass and draw perpendicular bisectors, because the perpendicular bisector will also find the midpoint of the segments. Maybe I'll do that with ST. Okay, compass. Set your compass to a certain size. No specific size, just more than halfway. You want circles that cross. And so if I go like so, draw an arc. I don't need to draw the full arc, I just need to draw like enough, and so there's enough. Flip the compass around to the other point and draw another arc on the other side. Now I'm not actually going to draw in the perpendicular bisector, I'm just going to use the compass, I'm going to use the protractor's straight edge to put a mark on the point exactly in the middle. I don't need to draw the actual line, just that point that's in the middle here, okay? And then of course clean up, we don't need those markings. We could do the same thing down here for S to T1. So center of the compass on S, draw like an arc. I'm not even drawing a full arc because I know I don't need anything in the middle. I'm just trying to create like these X's that are out here. But if you need to draw a full arc, or you do what I didn't draw my arcs long enough so I don't know where they cross, then maybe you do need to draw a longer arc to begin with. But now that I know where they cross, I'm going to take my straight edge, I'm going to line up the X's, I'm going to put a dot on the space. There it is. There's my midpoint of S to T sub 1. Okay. Maybe you don't have a compass, or you want another method. And so the other method that I have is to actually trace BT on tracing paper. So I got this patty paper, I got BT, and then selectively, carefully folding the tracing paper so that T matches B and get it perfectly spot on. Get the line to be perfectly spot on, and then put a crease in the tracing paper. This edge, this crease, will be the middle, because you take that half of the line and you put it on top of that half. So where the crease happens, put a dot, and then flip the paper over and put it back on the line. Make a mark. There's my midpoint. And if I connect midpoint to midpoint, I've made a mid-segment. There we go. Do the same thing for B to T sub 1. So B to T sub 1 is not that distance. I got to do a different measurement. This is with the tracing paper, a little cheese, and trace a line. Actually, I showed you the tracing paper. Let me show you a different method. The different method is to actually physically measure it. So I'm going to use millimeters, because millimeters will give me some decimal values that I can cut in half. Put the 0 on one point. Put the line of the protractor, the ruler's edge, along the line, and then be very accurate. It looks like 80 millimeters, 81, 82, 83. 83 millimeters. Half of 80 is 40. So half of 83 is like 41.5 millimeters. Super precise, but somewhere around right there, because that's the middle. You could either use the compass to make a middle, use the patty paper to make a middle, or physically just measure it to get a middle and then connect the points. All right. For each triangle, determine and label the midpoint ST as point X. So there's X. This is X, and this is Y. This is X, and this is Y. Connect the midpoints to form a mid-segment. Now, we're going to measure and compare the lengths, okay? So I need to measure BS. They don't like saying BS. That sounds like a slur or a diminutive term. So we're going to go the other way around. We're going to go from S to B. With using millimeters, mind you. Let's go inches. Let's mix it up. Let's show a range of capabilities. So setting the 0-inch mark on one end point, lining up the edge of the protractor along that. You go 0, 1 inch, 2 inch, looks like 2 1/4, a half, just under 3/4, technically 11/16. 2 11/16. Now I'm going to go up to like 12/16 and 10/16 would be like, 3/4 or 5/8. So now I'm going to go up to the mid-segment XY, measuring it, and I get, line up there, 1 inch, 1 1/4, 5. Let's see, 1/4 is 4/16, 5/16, 1 5/16. That's technically half the size. That's the key thing, right? A mid-segment is half of the opposite side. That's the takeaway. So 0, 1 inch, 1/4, 5/16 as well. 1 5/16. And other than this being like a little bit off, 11/16 is kind of the right size. 5/16, when you double it, you get 10/16. You double the 1, you get a 2. Double the 5/16, you get approximately 10/16. So yeah, totally true. Measure and compare. What do you notice? Well, for example, what I notice, the angles. These angles are the same. These angles are the same. So you're capturing the same angle. You're figuring that out. Like, this is just a smaller triangle version of this bigger one. This is a smaller triangle version of the bigger one. And then this base line is half the size of the big one. So the measure of angle TXY equals the measure of angle TSB. And let me move it all in here so you can see it. The measure of angle TYX equals the measure of angle TBS. Find those in the diagram. Each midsegment is parallel. I didn't mention that up above, but that's something else to acknowledge. Each midsegment is parallel to the opposite and congruent. Okay, parallel to SB and congruent. That's weird, but it works. Congruent to the other midsegment. I mean, they're all based upon how BS is the same for both triangles. Okay, what else? Each midsegment and is half of the length of SB. Thank you so much for watching this part 2 of the activity that we're talking about with triangle midsegments and triangle inequalities. Thank you for learning a little bit along the way and for sticking around. We do have more lesson material to follow. We're going to finish out this entire topic on triangles and triangle relationships. So thank you for sticking around. Thank you for clicking forward and getting to the next video and continue to learn a little bit more every day. Thanks. Bye.